Ladies and gentlemen, let me introduce your host for this afternoon, Christian Morales, EMEA General Manager and Vice President, Sales and Marketing Group, Intel Corporation.
Ladies and gentlemen, good afternoon, and very welcome to the Intel press conference. Very welcome to CeBIT 2014. And the topics you saw in this video about big data, about mobility, about security, it was absolutely incredible to see this mentioned by our Chancellor last night, by the Prime Minister of the UK, and also by the CEO of Volkswagen, who was talking about mobility and the big data and how the experience in cars is also changing. So I'd like to talk today about some key pillars of transformation that we are seeing in the marketplace, seeing around us, and also the changes in the experiences we are having with the devices. The first one is definitely on the devices and the multi-devices environment we are living in. And this is about the devices becoming much smarter. The other one is about the big data. We are generating more and more rich big data. There is more and more broadband needed, infrastructure needed, because the experience of the users keeps on evolving. And it's more and more about video, it's more and more about collaboration, it's about networking, social network, and social networks around the world. Then there is the Internet of Things. More and more devices connected to the Internet, and most of the devices that are today embedded, getting connected to the Internet. And this is a big change. When I started 30 years ago, in designs for the car industry, we had automatic gearboxes, we had dashboards, we had injection systems. They were embedded in the car. Now most of those applications are connected to the cloud. They are connected to the Internet because you need to be making decisions, because this is now part of an environment and a network, and you have to be dealing about those mobility devices in a very different way. And then nothing is happening today without a big focus on security, and we will be talking more about this. Very interesting trend going on in the world right now, and it is all the young generations joining the marketplace with a very different approach on networking, on collaboration, on innovation, and on teamwork. And this is what we call the generation of the millennials, and they're going to be more than 50%. They will represent more than 50% of the workforce by 2020. And 2020 is not a long way out, it's just 6 years out. So we're going to be standing here in 6 years from now, and 50% of the workforce in our company, in our environment, is going to be those millennials. And what is interesting about this new workforce is that they use at least 3 devices as an average. And I see it at home with my kids. They don't deal with one device only. They've got 3, 4, 5 devices. I remember my previous assistant, ponytail, PhD on IT, and he always had 2 PCs in parallel, 1 smartphone, if not 2, and when he needed to work on big data, he will have a very powerful desktop that he will also be using. So this is kind of the trend we are seeing, and it's absolutely fascinating. There is a lot of innovations going on, and the workforce is asking for new mobile devices with new experiences. And it's very interesting that until now, most of the interface with devices has been the keyboard, has been the mouse, and in the last 3 years on tablets, and now also on PCs, like 2-in-1s, it is a touch interface. We are going to be introducing voice command, perceptual computing in the way of gesture recognition, and also eye contacts and eye commands to those devices. And soon, the password to get into those devices will be our own password. We will not be using data anymore to get into a device. We are going to be using our face, and with our face we're going to get into our device. We are seeing, and we introduced those new products with the 4th generation core that was introduced in the 3rd quarter of last year, and it has been an incredible acceptance. And yes, the worldwide total available market of PCs is flat to down, but within this category of devices, there is a category that is growing double-digit, and it is the thin and light devices. 3 years ago, here at CeBIT, 7% of the notebooks were thin and light. Today, close to 40% of the devices are thin and light. And all-in-ones are also growing very fast, and all kinds of flavors of all-in-ones, be it the very large flat all-in-ones, or be it the new high-end desktops that we call the next units of computing, next generation unit of computing. So two-in-ones are really incredible experience coming up, and depending on whether you want more experience in terms of levels of performance, or you want more mobility, you can have those different flavors that are offered to you. If you look at some other devices we have here, such as, for example, ruggedized Core i5 based devices for very specific applications, or you have tablets, or you have all-in-ones. It's all kind of new devices that the ecosystem has been working on. We have been working with them to reignite this category and bring innovation and new experiences to the marketplace. I also want to talk about what technology can do in this environment of more and more digitalized economies. And more and more governments around the world, political leaders, ecosystems are working on how to use technology to make the ecosystems more competitive, more innovative, and also bring a key factor to everything we do, which is called sustainability. It starts with healthcare, for example. The current models we have on healthcare are not sustainable. We need to bring technology to make them more sustainable, starting with the services we provide, starting with the affordability of the services, and starting with how we cope with the trends of more aging populations coming up. Clean water, a key issue we have to keep on addressing so that we can provide clean water to all the citizens in the world. Technology is going to be absolutely key to make it happen. Then we have food, which is absolutely critical. And nothing of the above can take place without energy. You need energy for everything that happens in the society, for any activity, any economical activity. And sustainable energy is absolutely key, and we're going to be looking at how we are addressing those topics. It starts with the computing units. And this is why several years ago we introduced the state-of-the-art tri-gate transistors that brought not only more performance, but more consumer efficiency and more affordable cost, so that more applications can be developed around it and more people in the world can have access to it. And it then goes into the factories, the manufacturing capabilities we have. We need to run them in a much more sustainable and much more efficient way. And for the last 4 years, we have been getting the recognition in North America of being the largest green energy customer in that continent. If we look at the challenge, this is the challenge that we have in other countries. This is the challenge that most companies in the world have, and it is about, again, having sustainable energy and having affordable energy, and not only well-produced, well-distributed, but well-consumed energy so that we are as efficient as we can be, and the CO2 emissions as low as they can be. And we're also very glad to be working with the European Commission, Mr. Oettinger, who is the Commissioner for Energy, who is driving all those initiatives to make this region more competitive and bring more affordable energy and more sustainable energy to the marketplace. We do believe in breakthroughs that happen when you connect the solutions end-to-end. And here we have solutions that can go from the smallest possible devices and solutions you can think of to the most complex data centers. And if you connect them all and you bring solutions across this whole spectrum, you bring greater experiences and you can optimize the usage of assets across the board in this continuum. I would like to start with one solution here, which is in the home. Home is a place where we spend a reasonable amount of time and where a lot of energy is consumed. And in the home, if you look at today's connectivity complexity, I was just discussing with my neighbors, and I will ask them a couple of questions when they come on stage. I thought in my home I had 5, 6, 7 devices connected. At the end, I had more than 10. But I had 2 neighbors, one had over 30, and one was talking about an example of over 70 devices connected. we are bringing here a solution which is a breakthrough solution that is based and designed around Atom, the Atom architecture. This has been done in collaboration also with McAfee and Wind River to have a great integrated solution. Interestingly enough, here you have everything you need to run your home. You have the LAN connection, you have the coax cable connection, you have the LTE connection, and this is the power supply. And with this, you can run everything you need in your home. So this is the first time a solution like this, integrated like this, is introduced to the marketplace, and it is soon going to be available in this region and around the world. But this is a way of bringing a better experience, a more efficient usage of energy, and obviously a much easier use of all the experiences you want to have with much better security. And we have trials going on here in Germany, for example, with MVV, which is based out of Mannheim, here in this country. And there is now a pilot going on with a lot of customers, and this will be scaling in the very near future. Very important in everything we do in the industry, or in IT or in computing, it is to develop and bring standards. And we have been working with the ecosystem to bring the energy bus so that more innovation, more collaboration, more cooperation can take place, and better solutions can be brought to the marketplace. And this is a big announcement we are making here today with the EE bus that is going to bring a lot of innovations and a lot of new products to the marketplace in this environment of energy, and how to design better, safer, more efficient and sustainable devices. This is about the home. Then there is a very important part, which is the manufacturing networks and the manufacturing capabilities around the world. And here also, you need to understand what's going on in your factories. You need to understand what's going on in the manufacturing environment. Understand where the materials are, understand how the energy is being used, understand how the assets are being used. And for this, being connected and having a great solution is also very important. And we have recently introduced new architectures based on Atom and also on Quark. This is a Quark SoC 1000, for example. And this allows you to have what we call a transparent manufacturing environment, because you know where your assets are, you know where your devices are, and it allows you to connect both the legacy devices and also the new devices that you are getting into your manufacturing environment. So it's based on Atom and Quark. It has got an integrated software solution, and it combines all the security capabilities and also the real-time processing capabilities of Wind River and McAfee for security. So that's really a breakthrough design, and again, starting to be available in the forthcoming weeks. And again, great work here with the ecosystem to bring those solutions and have a better usage of energy, and also a better understanding of what's going on in the manufacturing networks. Analyzing the energy footprint to boost competitiveness is very important, and I just want to give an example here of what we have done here in Europe. It's in Ireland, with the Johnson & Johnson, and it's working with their manufacturing networks, on how to better connect the equipments and optimize the usage of energy and the efficiency of the manufacturing networks they have. It's about making the data flow available to make more real-time decisions, and the outcome of all this has been a 25% improvement in the efficiency, in the overall efficiency of the manufacturing network. So it's very, very important. It's a really huge gains you can have from a better transparency approach and better understanding of what's going on in your manufacturing capabilities, better connectivity, and better usage of the energy. So those are two examples. One is the home. The other one is the factories, the manufacturing networks. Now, how do you get all this energy to them? How do you get the energy to the homes? How do you get the energy to the manufacturing networks? We produce energy in the power plants, then we have to distribute them. To distribute the energy and make it optimized, you need to have what we call the smart grids. And the challenges of the smart grids is the complexity of what it is. If you look at Germany, for example, it's 1.8 million kilometers of smart grids. This is how you get from the production of energy to the distribution of energy, be it in the homes or be it in the manufacturing networks. The electric grid is the biggest machine that has ever been built by mankind, and it is extremely complex. And it's very difficult to understand where you have power, where you don't, if you don't go point by point to understand what's going on. And this is why bringing technology to it can really be a breakthrough, and it's very innovative. And 2 years ago, we decided to lead energy for this company out of this region. And I did ask Hannes Schwaderer to lead this initiative. So Hannes, I'm going to invite you here on stage to tell us, first of all, congratulations for what you have done so far.
Thank you.
And I just wanted to ask you, in those last 2 years, what have you encountered in terms of challenges and issues in this environment of energy production and distribution?
Yeah, I think the first experience was a big surprise. We heard about smart grids all the time, but we couldn't find a single solution that was an end-to-end smart grid solution in the entire market. An end-to-end solution with sensors on the one end and with big data analytics on the other end, with the computing, the communication, and most of all the end-to-end security in the middle. So we started off with a surprise, but it helped us to develop our own strategy. So we view the smart grid as an end-to-end solution, and we try to approach it with Intel as a building block and a connector of all these building blocks in this very complex grid infrastructure.
And so this is a theory. Anything in practice you have done so far?
We have done a lot of practice, and if I can tell you a little bit about it, I'll be happy to do so.
Be my guest.
Thank you. So, I do believe that we all agree that electricity is the backbone of every society, of every economy, basically of every country. And I guess we also agree that the cost of energy is a very important factor of competitiveness of every country. So this is the reason why companies, why people, why countries invest in smart grid solutions. Imagine we would know precisely how much energy will be generated in 24 hours from now. In particular with volatile resources like wind and solar that are hard to predict. Imagine we would know precisely how much energy will be consumed in 24 hours from now, with all the households, all the electric vehicles, all the factories, all the buildings. Well, this would allow us to match the generation of electricity with the consumption of electricity. We could provide electricity with the performance that is needed, at the time it is needed, and most of all, at the place where it is needed. This would help us to make this electric grid by far cheaper. It would help us save a lot of cost, starting with capital expenditure. With this 24-hour forecast, we could reduce the need for the build-out of the electric grid with copper massively, in particular with the high-voltage landlines that are not only a cost factor, they are mostly also a political factor. At the same time, this would allow us to reduce our operational expenditure. 10% of the overall energy that is being generated is generated as a reserve. Because today, we cannot tell how much energy will be produced and how much energy will be consumed and where in 24 hours from now. So 10% of the overall electricity being generated, for example in Germany, is only being used 4 hours per year. So obviously, this is a waste of energy, it's a waste of resources, and it's a waste of a lot of money. And guess what? You and us, as consumers, we have to pay for it. So if we had a reliable 24-hour forecast, this would not only help us to stabilize the electric grid, it would also help us to stabilize the cost of electricity. To be honest, nobody has ever built such an end-to-end smart grid solution. So we decided, first of all, we want to do it end-to-end, as I mentioned, but secondly, we decided we need to do it step by step. And in order to determine where we wanted to start with, we talked to our customers where were their biggest pain points. In a very close collaboration with Westfalen-Weser Energie, we developed several solutions for smart grids, for example, for intelligent substations. So rather than me telling you what we did, let's ask a real customer. Westfalen-Weser Energie is a grid operator based in the north of Germany who is serving more than 1.3 million customers. So please welcome the Senior Vice President Business Development of Westfalen-Weser Energie, Detlef Gieselmann. Detlef, welcome.
Hi Hans, nice to be here with you.
Welcome at CeBIT. So I guess everybody is curious to hear why your company is investing in smart grid solutions.
Yes, Hannes, as you know, we have more than 1 million small power producers in Germany right now. For example, farmers who have a PV device on their roof. That's no problem by itself, but the problem is that the power is fed into the grid in an uncontrolled, unmanaged and unpredictable manner. So our responsibility as a grid operator is to keep these grids secure and reliable, although they have never been designed for this load and this volatility. Just to give you an imagination of this problem, at peak times, these 1 million renewables in Germany generate more energy than all conventional CO2 emitting power plants we have in Germany right now. So, no matter if we need this power or not, it's fed into our grid. So to manage these things, we need three things: transparency, transparency, and transparency. Otherwise, there's a danger that our grids become uncontrollable. And this with all consequences, not only on the local, but also on the national and even on European level.
So how does Intel help you with this challenge?
Well, the Achilles heel is the so-called last mile of our grids. Here we have the least transparency and the most disruptive factors due to the uncontrollable feed-in from renewables. We are working with Intel to bring transparency to the secondary substation which controls the last miles of our grids. With the help of Intel, we have installed Intel core-based analytics in secondary substations, analyzing more than 1,000 different data points and sending back this data to our control rooms to let us see what's really happening there.
So Intel is known as a chip company. Why are you working with Intel in this project?
So yeah, we think that Intel is the only company that has the end-to-end technology and the covering layer of security which we need to solve these problems. Sorry. So, and to have the overall connection from the edge to the data center. This is crucial for us. Secondary, we are convinced that Intel is the only company which can provide us with a scalable technology to bring down the costs. That's extremely important to us because you have to imagine we have more than 1 million secondary substations even just in Germany. And we need to smarten up about half of these substations to get the transparency we need in our grids.
So what comes next?
Well, today we have 2 substations connected which generate data for more than 1,000 data points. This could be integrated manually quite easily. But imagine we have thousands of substations just in our grid at Westfalen-Weser Energie. And just imagine all these, or many of these substations firing data at us. So we need big data analysis to handle this data, and we need predictive analysis to be informed and to get an imagination what happens in our grids in the next 24 hours. And we need to work together with Intel to be able to make this technology as secure as possible.
Thank you very much, Detlef. Thanks for joining us today, and thanks for the deep insight into the business of a grid operator. So you just heard it from Detlef that the data center is of extreme importance for the energy sector going forward. Now, this is of course not only true for the energy sector. Data centers are of crucial importance for any vertical business, for any vertical industry. They are particularly important when you run critical infrastructure like the electricity. Detlef also mentioned that with the help of Intel we installed sensors that measure thousands of measurement points in a single substation. Now they also operate 1 million substations only in Germany, so there are millions of devices out there communicating. And this is exactly what we try to describe with the Internet of Things. Billions of devices that are connected and that communicate. And these devices might look all different. Some are sensors in a secondary substation, some are a smartwatch, a smartphone, a smart car, a device in a smart factory, but all of these devices have one thing in common. They generate tremendous amounts of data. And that is why we need data centers with completely new capabilities. Most of all, we need the capability in the data center to transform these data into information. Information, on the other hand, is a very valuable good, and it might be a valuable good to many new customers we don't know today, but most of all, we will develop a lot of services around the data and the information out of the data. Now, more services attract more customers, they want to make use of these services, and they install more devices. And I guess you get it, these devices, more devices generate more data and generate a better requirement for more data centers with new capabilities, and this is what we call the data spiral. This is why we believe that the data center business is facing a tremendous growth opportunity. This is also why we are pretty proud of our latest product introduction, the Intel Xeon processor E7 version 2. This microprocessor has been exactly designed for handling the data explosion that the Internet of Things is bringing along. Now, it's nice to analyze your data and find out why you had a blackout in the past. It would be even nicer if these data would help us to predict that a blackout might happen in the electric grid, so you can manage and interact and manage your grid so the blackout doesn't even happen. But in order to be able to interact in real time, your data needed to be processed in real time, so we need real-time data processing in our data centers in critical infrastructure. In order to allow that, you need the maximum of performance. That's very simple. Compute performance counts. And in order to enable that compute performance, you need very large amounts of memory. As a matter of fact, when we talk about real-time data processing, we talk about terabytes of data that need to be held in memory to allow the processor to do its work. Needless to say, it needs a lot of reliability. If somebody runs their business based on data analytics, this becomes mission critical. So you need a 24/7 uptime. Last but not least, you need the data analytics capabilities inside the hardware so the highly optimized software can make the best use of it. Highly optimized software like SAP's HANA database or Intel's Hadoop analytics platform. We cannot do without talking about cost. If you want to keep the cost reasonable for such complex solutions, you need only three things. It's the utmost energy efficiency, a maximum performance, and a maximum of uptime. And this is the reason why the new Xeon processor E7 version 2 comes with 2 times the performance relative to the previous generation to allow for an utmost of fast data processing. It comes with 3 times the memory to allow for advanced real-time analytics. It comes with 4 times the I/O throughput, and it comes with 5 nines. 99.999% availability for a reliable 24/7 uptime. Now, the result of that is stellar performance. You get the best performance you can buy for money for big data analytics on this new platform. And this is the result of a lot of time, many years, and many dollars of research and development. And it's not only research and development for the best possible processor architecture, it's also a lot of investment in the market-leading, in the world-leading manufacturing process that we are pretty proud of. Ladies and gentlemen, Datability, big data analytics is the slogan of this year's CeBIT, and of course we do not only work on big data analytics with utility companies, we also talk and work with market leaders, technology leaders that provide equipment for the utilities. Before I give back the stage to Christian Morales, let's have a look at the video statement of one of these technology leaders, of his view of the role of big data analytics and his view that Intel is going to play in that.
My name is Laurent Schmidt. I'm the Vice President for Strategy and Innovation at Alstom Grid. Alstom Grid is a global leader into control room and automation technology for smart grid systems. We have developed a strategic relationship with Intel when it comes to embedded intelligence and security. So smart grid are required to interconnect with much more energy resources than before, because renewables are very distributed, and it is also about connecting end consumers into the grid for the grid operators to make sound decisions on energy dispatch. As a consequence, we are having much more data flow back into the energy management software to be able to make that real-time decisions. So the quantity of data which is to be dealt and aggregated there is exploding. So we are collaborating in that space with Intel on developing benchmark on our current architecture and future ones, and being able to anticipate new technology developments in areas such as Hadoop, which we think are very promising to facilitate the growth of this data flow into these energy management software. So security is core in the development of future smart grid systems. Because energy systems are critical to cities and countries, we have to take into account specifically the risks of cyber attack into the design of future smart grids. So I expect this industry to embed solutions and best practices from other sectors and adapt it to the specific needs of our own environment.
Thank you, Lettler. Thank you, Hannes. So this was an example of a deep cooperation and collaboration with the ecosystem to absolutely bring breakthrough solutions to the marketplace and keep on innovating and bringing those solutions to make everything we do much more affordable and much more sustainable. And if we want to keep on solving big problems, we need to approach it this way, meaning open standards, meaning collaboration and cooperation with the ecosystem. Now, this brings me to the importance, and you heard it from the previous interview from the Vice President from Alstom, the importance of security. And we talked about combining intersecurity under one roof, which is hardware we have at Intel plus some software, and the incredible assets that McAfee has brought to the house. And you have seen some of the very famous malwares we have seen on the next, like the Stuxnet that was discovered in June 2010, that got a tremendous negative impacts in the world. The Duke, which is a collection of computer malware that was discovered 1 year later in 2011. So there is definitely a lot of attempts of malware to come into the networks. And I'd like to have a conversation now with Raj, who is our CTO of McAfee Europe, Middle East, and Africa, to come and join me here on stage. Raj, if you join me. Welcome, Raj. I want to thank you and congratulate you also for this great book you have written on the cybersecurity and the smart grids. So that's a great work you have done there. And let us know, Intel, McAfee, Wind River, we have been working together. In your view, from a security standpoint, what is unique about this approach?
Well, let's first of all have a look at the way that we've managed security in the past. Intel have done a great job of developing hardware, and then they would then walk away, and the security providers would then need to come in and put security software on top of that. And we led a very siloed approach. You do your bit, we do our bit, and we probably won't talk. And I think the threat landscape has kind of recognized that. You mentioned two particular malware examples. It's the tip of the iceberg. The threat landscape is evolving, so if you look at the way malware works, it's getting lower down the stack. So security software in itself needs to get deeper, needs to work harder as well. So you mentioned about the initiative. We're announcing today the McAfee, Wind River, and Intel collaborative approach with an energy initiative with regards to addressing cybersecurity challenges for the future. Working with Intel and Wind River, what we're able to do is work with our energy partners to start to provide security solutions for an end-to-end smart grid.
Thank you, Raj. And when we look at the Intel security and McAfee, how can we address the smart grid challenges we were just listening about?
That's a good question. You know, we have to look at it in two ways. So we mentioned about brownfield or sort of existing installations. And when we sort of talk about energy assets, those installations have probably been around for 20 to 30 years and maybe around for another 10 to 15 years. So we have to start to look at solutions that can sort of provide security around the existing assets. Then we have the greenfield sites, in other words, security and privacy by design. And we're beginning to see some of the fruits of that. You know, in Germany, for example, there's almost 1 million secondary substations. So we're dealing with a very geographically dispersed area, and we're dealing with threats that really evolve in real time.
So what are the collaboration and initiatives you're working on right now?
Well, so there's a few right now. So, well, one of the first ones we're doing, obviously, you know, we're working with Detlef and the team as well, is around a concept that we call fork planning. And, you know, I've touched upon the geographical nature of, you know, the energy assets. What we're able to do is, from a central location, we're able to remotely manage assets within a secondary substation. And I think if we start to look into the future, we can potentially even not only fully automate that, but do this in real time so we don't have to have maybe an administrator to wake up, have a cup of coffee and then decide to do something, which is the first area. With Alstom, for example, we published a white paper on security in the smart grid, which came out last year. And we're now doing work specifically looking at one of the key areas that most consumers are worried about, which is privacy in the smart grid. So lots to be excited for, I think.
Great. And you told me a number which is absolutely incredible. How many devices do you have connected at home?
Right, so I just want to be clear here, all right, you're putting me on the spot. So I have 31 IP-enabled devices at my house. I don't personally see that as a lot, but everyone's judging me at the moment, so I think maybe they are.
And security, how do you handle security?
You know, my biggest threat vector is my 8-year-old daughter. Yeah, she's managed to gain access to my iTunes password, so we have to keep changing that. We install security software, and it's my fault. I taught her how to use Metasploit at 3 years old, so I hold my hands up to that.
Very good, right, thanks so much.
Thank you, Christian.
So those are the 4 key pillars of a transformation we are seeing in the industry right now. The multi-devices environment, to give you an idea, it's about 300 million PCs in the world. It's about 300 million plus tablets in the world. It's close to 1 billion smartphones. And it is several billion Internet of Things devices in the world. And this forecast we had of 15 billion devices connected by 2015 looks like it's gonna fall short. And by 2020, the forecast was that there will be around 20 billion devices connected. It looks like it's going to be more like 50 billion. So this is about the multi-devices environment transformation that is taking place, about the Internet of Things, about the big data, because this is generating big data. And obviously you need to have analytics to be able to extract the pieces of information and data you need. And if until now, a terabyte of data, you will need several days to analyze it. Now you can do it in some hours. Soon you will do it in some tens of minutes and then in some minutes. So this is the importance of being able to analyze so much data and to extract what you need out of it to make the right decisions. And then obviously security on everything we do, because imagine 50 billion devices connected, those are combinations of potential malware. So we are going to need a great collaboration with the industry, with the ecosystem, to bring the absolute best solutions to the marketplace from a security standpoint. And I wanted to show you a video now on a glimpse of what the future could look like in terms of this environment of multi-devices environment, application, big data, Internet of Things. And so let's watch this video, and then I'm going to be concluding. is how we anticipate the future of those connected devices is going to look like. And it's going to go with solutions from the absolute smallest sensor that you need to measure what's going on in the front, get some intelligence out of it with microprocessors there, for example, a Quark architecture, then go into solutions around Atom or Pentium or Core, and then go into the high-performance computing centers to calculate and understand what's going on from a data standpoint, store it, have the data centers, and go and extract what you need to make the decision. So from an end-to-end standpoint, architectures and solutions that are going to be compatible and are going to base around open standards so that the ecosystems can keep on bringing great experiences and new solutions to address some of the big problems we have to face. And today we want a little bit of a deeper dive in the one which is the energy. So with this, I want to thank you very much for your attention, for being here with us tonight. I want to wish you a great CeBIT 2014, and let us invite you, please, onto our booth, and you will be able to address questions or comments to specialists on any of the topics we have just been talking about, and we would like to be sharing also some drinks with you. Thank you very much, and again, have a great CeBIT.